certain peptides and how they associate with the surfaces, and in some cases, proteins that can spontaneously associate with that bilayer, like a pore-forming protein, can be added after the membrane is formed. So but for most proteins, you have to keep them in a detergent or a lipidic phase to keep them happy. So the question is how you bring a protein that's been isolated in detergent to the surface or in a liposome. And so I'll show you examples of what we're thinking in terms of using liposome exchange with the assembled. Again, you pre-assemble the TBLM, and some examples right now only at the level of exchange that lipids and cholesterol can be exchanged. But the idea would be to bring the cargo to the surface of the liposome. And the other approach that we're looking at is first tethering the membrane protein to the surface, and then assembling the bilayer around the protein. So you capture the protein on the surface, and then you basically wash out the detergent with lipids after. And that last step actually we'll get to, but actually solves one of the challenges in when you're assembling proteins on a surface is that there's an orientational issue. So if you want your proteins to come in all in one orientation, if you do it randomly, they can be equal likelihood to be up, whatever is up or down, it can go in both ways to your bilayer. To transfer from liposomes to the surface, we have examples now from the group where you can basically wash liposomes over the bilayer surface, and if you label your lipids with fluorescent tags, you can see that the actual fluorescence, these green fluorescence dots here, showing that the lipids actually exchange. So they basically exchange into the membrane and then wash the liposomes off, and you see the residual green fluorescent